Hello, my dear friends and students. Today, in 10th class mathematics, polynomial, second chapter, 2.1, let us learn. In first exercises, this only one problem is there. Let us learn. Yes, first of all, before going to learn these graphs, about graphs, let us learn what is polynomial. Polynomial. Polynomial means Poly means what is polynomials? Polynomials means poly means many. Nominals means terms. Polynomial means many terms. Poly means many and nominal means terms. It is. Yes, polynomials. If this polynomial is a separate subject, is this polynomial is the separate subject? A newly subject? No, it is not newly one. It is the part of the algebraic expressions. Algebra we know. Algebra means constants and variables. It is a part. Suppose algebra, it is the algebraic expressions. Polynomial is also one part. Yes. What is polynomials? What is algebra? What is polynomial expressions? What is algebraic expressions? We have to know, isn't it? Yes. Let us write 2x square minus 8x plus 6 by 2x. What is this? Is this polynomial? No. Because in the denominator place, the variable should not be there. Variable should not divide this. So it is not a polynomial. Yes, it is just algebraic expression. What is polynomial? The exponents, the powers of the variables should be whole numbers. Whole numbers means 0, 1, 2, 3, 4, 5, 6. Those are the whole numbers. Here you see 2x square plus 3x plus 7. It is a polynomial because the exponents, you see, the powers of the variable are whole numbers. Here you see the x power is 2, x power is 2. Here x power is 1. Here no x, it is constant. Constant means 7x to the power of 0. X to the power of 0 is equal to 1. 7 into 1, 1, that's all. That means here 0. Isn't it? Here all 0, 1, 2, all are the whole numbers. All are the whole numbers. Yes, the powers of the variable should be whole numbers. And another one, let us see. 2x square plus 2x cube plus 2x to the power of minus 2 plus x plus 7. It is also not polynomial. Why? Because the power of the x is not whole number. In the whole numbers, their minus values are there. Now 0, 1, 2, 3, 4, 5, those are whole numbers. Isn't it? Yes, it is integer. Minus value means integers. Yes, it is integer. It is also not polynomial. But if it is like this, it is a polynomial. It is a polynomial. Suppose here is there 2 polynomial. That means, and another one, 2x square by x. Is it a polynomial? It is not a polynomial. Why? We can write 2x square, here variables are same, minus this power is what? 1 minus 1. We can write like that. We can write like that. And minus values also not considered because the powers of the variables should be whole number. Yes. Now what we have learned, polynomials means many terms will be. What is there? Is it a separate branch? It is not a separate branch. It is the part parcel of the algebraic expressions. But what is polynomial? Polynomial means the powers of the variables only whole numbers. That is polynomials. Yes, let us come to the point. First, in this exercise, in this 2.1, only one sum is there. Yes, in the Cartesian plane means sum, and that is in Cartesian plane, graph, a geometrical representations will be. That means in graph paper, you think it is a graph paper, Cartesian plane. It is all geometrical representations. Yes, what did he ask? The graphs of y is equal to p of x. It is y is equal to p of x. P of x means it is a some polynomial. P of x means it is a polynomial. Polynomial are in x terms. Polynomials are in x terms. P of x. Yes, y is equal to p of x. You see how to draw the graphs. I tell you later. In the next exercises, those questions will be. Now let us see y is equal to p of x. With this equation, we can draw we can write the table x and y, like that table we can prepare. After preparation of the table, we can draw this graph. I tell you in the next exercises. First of all, you see y is equal to p of x. Yes, y is equal to p of x are given below. These are the tables. We have y is equal to p of x. We can prepare the tables. As per the tables, we draw the graphs on the graph paper for p of x. Find the number of zeros of p of x in each case. Number of zeros. Number of zeros means at which real value of the variable, the polynomial is 0. That is the 0 of the polynomial. You see, the real value at which polynomial becomes 0 is called 0 of the polynomial. Yes, when it becomes 0, that is the 0 of the polynomial. How? Then zeros we have to find. When zeros, how do we can find the zeros? When the line touches the, suppose it is a graph, it is y-axis, y dash, x-axis, x dash. In this Cartesian plane, if suppose on a graph it is how many zeros are there? No zeros are there, because it touches it intersects it cuts the x-axis only. When it cuts how many times the graph, how many times this graph, how many times this line, how many times this curve touches the x-axis, that number of zeros are there. Suppose for linear polynomial, 1 zero will be quadratic, 2 zeros, cubic, 3 zeros, like that zeros will be in the zeros of the polynomial. Yes, then suppose the graph is like this, the graph is suppose like this, there is no zero at all, because this graph, this line did not touch the x-axis. 0 of the polynomials, no zeros are there. Yes, another one, let us see. Yes, it is x-axis. Yes, suppose it is. It is x, it is y. How many zeros are there? At how many places this line intersects at only one place. It only one place. That means only 1 zero. Only only 1 zero. We have to write like that, because it touches, it crosses, it intersects this line intersects the x-axis. How many places? Only one place. Yes, the lines, the graphs will be like this also in the parabola type. If parabola means it is curved, it opens upwards. Suppose if it is there, open downwards. These sort of lines are, these sort of graphs, this sort of curve is the parabola. What is parabola? Yes, let us see. Now write the parabola, right? We have written, x-axis, y-axis. Yes, sir. How many zeros are there? This curve, how many places it touches the x-axis? See, one place, two places, two zeros. How many zeros? Two zeros. Suppose, let us see, how many zeros is this curve? How many how many places it touches it crosses it intersects the x-axis? See, one place, two place, third place, fourth place. Four places it touches touches the x-axis. X-axis. So four zeros are there. Like that we tell. Yes. Let us go to the problems. Yes. Here, number one. What is how many zeros are there? In each case, we have to find how many zeros are there. This graph, this line touches the x-axis at any places? No, this line is parallel to this line. This line is parallel to the x-axis. No, where? No, it touch. So it did not touch the line. The line is parallel to the x-axis. Axis. It did not intersect at any point. So no zeros. No zeros. There are no zeros. Yes. Let us see second one. Yes. In this second one, what is it? It is second one. Second one. Yet how many places this line touches? Let us see. You see, this is the x-axis. X-axis at only one place. At only one place the line touches. Yes, the graph touches the graph or line or curve touches touches the x-axis. X-axis only at one place. So 1 0. That is the answer. Only 1 0. Let us see third one. Let us see the third one. Yes. Yet how many places this curve touches this graph touches the x-axis? Yes. This line touches the x-axis at how many places? Here 1, here 2, here 3. We should not take into account of the this x-axis, not y-axis, isn't it? Yes, only x-axis. 1, 2, 3. Yes, the graph or line touches the touches the x-axis. Yet how many places? 3 places. So 3 zeros are there. 3 zeros are there. How many zeros are there? 3 zeros are there. Let us see fourth one. Yes. How many zeros are there? You see the curve is parabola. Parabola means if it is the parabola, that means open this parabola open upwards. This parabola opens downwards. Yes, this curve is called this parabola. Yes, how many places it touches the x-axis? 1 place, 2 places. That means the graph touches the touches the x-axis at 2 places. So there are 2 zeros. There are 2 zeros. 2 zeros are there. Same. You see, fifth one I over sixth one. How many zeros are there? Let us see. Here the curve or this graph, this line touches how many places? You see, 1 place, 2 place and 3. 3. 1, 2, 3. But we should not take into account of this y-axis. Only we have to take into account of the x-axis only while finding the zeros. Yes, at 3 places. Yes, the graph touches the x-axis at 3 places. At 3 places. So there are 3 zeros. There are 3 zeros. Like that we can write. It is very easy. It is first exercise 2.1. First exercise, only one problem is there. Yes, sir. Next, in the next video, let us go to the second exercise. Thank you.